Assalamu alaikum dear students. This is our next problem. Problem having been chosen from the book Modern Physics by Kenneth S. As usual, we first come to its statement. Okay. Its statement is when superconducting tantalum metal is illuminated with a beam of photons, it is found that photon wavelengths of up to 0.91 millimeter, standing for 10 to power minus 3, okay, milli 10 to power minus 3, micro 10 to power minus 6, nano 10 to power minus 9, okay. It is found that photon wavelengths of up to 0.91 millimeter are sufficient to destroy the superconducting state. That is, it is minimum energy required to do this task, okay. According to the VCS theory, find the energy gap and critical temperature for tantalum TA, okay. As usual, we first go through helping tools which will be used or employed in our solution, okay. Helping tool number 1 is that VCS gap energy in superconductor is given by Eg, where G is written as a subscript of E, is equal to 3.53 kTc, okay. Here Tc is critical temperature, K is Boltzmann constant, okay, and capital E small g having been written as a subscript of capital E stands for energy gap or energy gap, okay. So BCS gap energy in semiconductor Eg is equal to 3.53 kTc, where C is written as a subscript of capital T standing for critical temperature, small k is Boltzmann constant, okay. Now we move to helping tool number 2. Momentum of a photon P is equal to photon energy capital E divided by small c, that is speed of light in vacuum. This alternatively becomes equal to hf, where h is Planck's constant and f is the frequency, divided by c, speed of light in vacuum, okay, as you in the previous step. This alternatively becomes equal to h over lambda, where lambda is wavelength. Now we move to tool number 3. Dear students, tool number 3 has been used so many times that for the time being we skip this tool. However, we will use the relevant data from this helping table, okay. Now we come to our solution. We know that momentum P is equal to E over C, which alternatively becomes equal to hf over c, which alternatively becomes equal to h over wavelength lambda. This implies that capital E is equal to hc over lambda, okay, because here in order to derive this form of the above expression we will take E over c equal to h over lambda, okay. We will omit remaining two equivalent factors for the time being, okay. First and third equivalent factors will be omitted or neglected for deriving this equivalent form, that is E equal to hc over lambda. Okay, first and third factor will be neglected and only second and fourth equivalent factor will be taken into consideration, and we will get capital E energy equal to hc over lambda. H is Planck's constant, C is speed of light, and lambda is wavelength. Dear students, value of lambda has been provided in this statement, which is 0.91 millimeter. Milli stands for 10 raised to the power minus 3. Okay, so in place of 1 m, which stands for milli, we have replaced it by 10 raised to the power minus 3. Now, H Planck's constant and value of C both are given in the table, this table, third table. Okay, these two values have been separately given in this table, and combinedly Hc is also given this. Okay, Hc equal to 1240 electron volt nanometer or million electron volt femtometer. Okay, so here we have directly chosen the combined value of Hc, while value of lambda has been provided in the problem statement. Okay, so remaining will be only simplification. Okay, when we write this, dear students, here meter will be cancelled with meter and nano will be replaced with 10 to power minus 9. Okay, 10 to power minus 9 will be in the numerator and 10 to power minus 3 will be denominator, and hence their equivalent result will become 10 to power minus 6. Okay, so it will become 1362.64 electron volt into 10 to power minus 6. Dear students, we know that 10 to power minus 3 is milli, 10 to power minus 6 is micro, and 10 to power minus 9 is nano. So we can write it in terms of this symbol mu. Okay, so this becomes equal to this. Now if we want to convert this mu into nano, then this figure, that is 1362.64, will take the form as 1362640 nano electron volt. Okay, okay, because micro is equal to 10 raised to the power minus 6 and nano is equal to 10 raised to the power minus 9. So when we will convert this micro into nano, we will have to multiply the above factor with 1000. Okay, so alternatively it has taken this form. Okay, and if we go again in terms of milli, then it will take the form as 1.3. Okay, we can also from here take this value directly. Last step can be derived directly from this step, that is 1362.64 electron volt into 10 to power minus 6. When we want to convert this 10 to power minus 6 into 10 to power minus 3, then we will have to divide this with 1000, and hence the resultant value will become 1.36264 million electron. Okay, all the values are correct and convey the same result, correct answer. This is our just discretion that we have written this quantity in such various patterns. Okay, so our solution has become quite clear that E, that is minimum energy, which is also equal to energy gap, okay, has become equal to 1362.64 micro electron volt or 1362640 nano electron volt or 1.36264 milli electron volt. Okay. Now, dear students, if we take into consideration the statement of the problem, then we can conclude that as per existing situation, E is equal to Eg, which is equal to energy gap and which is equal to minimum energy of photons. Okay. So here the term which we have denoted by E will be shifted to simply Eg. Okay, because there is no difference between E and Eg in this case. Okay, this is the minimum energy required to emit those photons, and hence this E is equal to energy gap. Okay, as per existing situation, E may also be denoted by Eg, and we know that Eg is energy gap, and this is energy is also the minimum energy of photons. Okay, now according to BCS theory, energy gap is equal to 3.53 Boltzmann constant K into critical temperature Tc, where C is written as a subscript of capital T, equation number 1. This result has been shown as a helping tool. Okay, perhaps helping tool number 1. Okay, where capital E small g, where small g has been written as a subscript of capital E, is the energy gap. Small k is the Boltzmann constant, and Boltzmann value of Boltzmann constant is provided in the tool number 3, in which a very comprehensive table has been shown, in which values of various physical constants have been provided to great accuracy. Okay, where Eg is the energy gap, K is Boltzmann constant, and Tc is the critical temperature. We have to find out critical temperature. So we will reshape equation number 1 in this form, that we will keep Tc, critical temperature, on one side and all other factors on the other side of the equation, and hence critical temperature Tc, it becomes equal to energy gap Eg divided by 3.53 volt into small k, that is Boltzmann constant. Dear students, we have calculated energy gap, which is also equal to minimum energy of photons, which is okay in the above step, in the previous section of this video. Okay. So we will put value of Eg in this expression. Moreover, 3.53 is already a constant, and a small k Boltzmann constant is also a constant, and its value has been provided in the table shown in tool number 3. Okay, so we will just put the value of Boltzmann constant K, and hence we will simplify this expression. When we simplify, we see that electron volt will be cancelled with electron volt. Moreover, 10 raised to the power minus 5, which is in the denominator, if shifted to a numerator, it will take the form 10 raised to the power plus 5. Okay. Moreover, small m appearing in the numerator does not stand for meter, it stands for milli, and milli is equal to 10 raised to the power minus 3. Okay, so this milli will be replaced with the 10 raised to the power minus 3. This 10 raised to the power minus 5 has been shifted to a numerator, and it has become plus. So their combined effect will become 10 raised to the power plus 2 in the next step. Okay, so after simplification we get the result: critical temperature Tc equal to 4.48 Kelvin. Okay, critical temperature Tc becomes equal to 4.48 Kelvin, and this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.